way down, the reason we drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over. We down, we're getting on fire, we're raising up higher. The bottle is up, we're over the top, it's time to get wild. The time of a life, it's happening now. We're out of control, together we're rolling over and over. We down, the reason we drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over. We down.
Ladies and gentlemen, may I have your attention, please?
So, for this video experiment, the objective is to determine the most appropriate and rapid method of ethanol content in alcoholic beverage with completed alcohol content and some sample amount. So, the introduction of this experiment is gas chromatography is a technique for separating components based on their volatilities based on difference of boiling point. It is also called as carrier gases. In this gas chromatography, the component of a vaporized sample are separated as a result of being partitioned between a mobile gaseous phase and liquid or a solid stationary phase held in the column. The separation principle is the principle of light dissolve light, where light refer to the polarities of the analyzed and the immobilized liquid stationary phase. The polarity of organic functional group increase order where aliphatic hydrocarbon, olefins, aromatic hydrocarbon, halide, esters, aldehyde, ketone, alcohol, aminide, amidase, carboxylic acid, and water. So, polarity of the stationary phase should match that of sample components. When the match is good, the order of elution is determined by the boiling point of the eluents. So there are 5 factors affecting gas chromatography separation. First is polarities of compound temperature, flow rate of the gas, volatilities of compound, and length of the column. So we go to how does gas chromatography work. So there are 4 components in this gas chromatography, which is gas carrier, sample injection system, columns, and detector. So first, how it works, the eluent or the gas carrier is introduced from a gas cylinder outside the machine. It's called the carrier because that exactly who it does carry the sample while studying through the machine. In gas chromatography, the carrier gas is the mobile phase. Second, the rate of flow of the carrier is carefully controlled to give the clearness separation of the component in the sample. Third, the carrier enters the machine through an inlet port or splitter. Fourth, the sample being measured is injected into the carrier gas using a syringe and instantly vaporized. 5. The gases that make up the sample separate out as they move along the column, which contain the stationary phase. Typically, it is thin coating on the inside wall of the column. The column is very thin, capillary sometimes as much as 30 to 60 meter or 100 to 200 feet long coil, and entirely contained inside an oven that keep it at a high enough temperature to ensure the sample remain gas form. The temperature of the oven can be carefully controlled. 6. As the sample separated out and its constituent gases travel along the column at different speed, the detectors sense and record them. But various different detectors can be used, including flame ionization detector, thermal conductivity detector, and mass spectrometer. Lastly, the data analyzed attached to the machine draws chromatograph chart with peak corresponding to the relative amount of the different chemical in the sample.
Next, for the materials, 26 alcoholic beverages, including 12 distilled spirits, which are whiskey, brandy, Khao Liang wine, rice wine, Misu Tao, and medicine wine, and 14 non-distilled spirits, which are millet wine, grape wine, fruit wine, Shaoxing wine, and beer, were purchased from supermarkets in Tainan, Taiwan. The purity of ethanol, acetonitrile, 1 propanol, isopropanol, acetone, 1 butanol, and 3 butanol were more than 99.5% and were obtained from ALPS Taiwan. There were 2 methods were involved in this process, which is direct injected gas chromatography method and distillation hydrometric method. Firstly, for direct injected gas chromatography method, beverage sample solution 0.5 ml was dispensed into 1 ml capillary sample vial, and then 5 ml of 1% internal standard solution equivalent to 50 mg was added. After mixing, 0.1 microliter of the sample solution was injected directly into a gas chromatography with shearing. Ethanol content was calculated according to the equation ethanol mg per ml equal to AS per AIS times WIS per RRF times 1 per V, in which V equal to sample volume in milliliter. Next, for distillation hydrometric method, alcoholic volatile compounds in beverage samples were separated by distillation, and the gravity of the distillate was measured by hydrometer. The ethanol content was then converted. Besides that, the gas chromatography system and the type of detector that used in this experiment was flame ionization detector (FID). Other than that, the type of inlet or injector port that used in this process was splitless injection. The size of column was 30 meter times 0.53 mm. Furthermore, nitrogen in the flow rate of 2 ml per minute was used as the carrier gas. Next, for the oven temperature, it was set initially at 45 degrees Celsius for 2 minutes and then increased to the final temperature of 245 degrees Celsius in 1 minute at the rate of 45 degrees Celsius per minute. Last but not least, injection volume was limited to 0.1 microliter.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur HAIFAA HANANI, and today I would like to talk about ethanol sample. The diagram shows the chromatogram result of the ethanol. The average percentage of alcohol content in ethanol is from 3 to 6%. The retention time of ethanol peaks in the chromatogram level in the diagram was 3.35 minutes.
Figure shows that the chromatogram result of the red wine spectra on chromatogram. The average percentage of alcohol contents in this drink is 16.0%, and the retention time of ethanol peak of this chromatogram is at 3.35 minutes.
My name is Amilen, and I will talk about the last sample whiskey. The figure shows the chromatogram result of the whiskey grain. The average percentage of alcohol in all the whiskey tested is 40%. The retention time of whiskey peats in the chromatogram labeled in the figure is at 3.31 minutes.
So the table shows the result for sample, its retention time and the average percentage of alcohol content. Ethanol elite first compared to acetonitril is because ethanol has a lower boiling point than acetonitril. Ethanol boiled at 78.37 degrees Celsius, but acetonitril boiled at 82 degrees Celsius.
Next, we will move on to the discussion. There are three samples used, which is ethanol and the acetonitrile, red wine, and the whiskey. The gas chromatography is a good choice of method for analyzing alcohol, as it is focused on analyzing the volatile compounds. The detector used in this experiment is the flame ionization detector (FID), as it is good in detecting hydrocarbon. Next, the stationary phase used in this experiment is capillary column, while the mobile use is the carrier gas such as helium and nitrogen. The helium provides a good efficiency and analyzing time, but the nitrogen is the best in providing good efficiency in gas chromatography.
In the experiment, to get the retention of ethanol, FID was used and are set at 240 Celsius by using Zebron ZB-BAC1 as the column stationary phase. The column temperature is 40 Celsius. Mobile phase used is helium gas with the flow rate 2.57 ml per minute. Ethanol use is the lowest concentration to know the retention time of the ethanol and are used as a standard compound. Sample was injected by using split mode, and after the analysis was done, the retention time is 3.35 minutes.
For wine, the detector used is FID2 with the temperature of 240 degrees Celsius by using Zebron as the column. The column temperature is 40 degrees Celsius. Mobile phase used is helium gas with the flow rate of 2.57 ml per minute. The injection mode for this experiment is split mode. Since the average alcohol for wine is 16%, the retention time obtained is 3.35 minutes.
Lastly is the whiskey. Whiskey has the most alcohol content, which is 40%. It uses a spitless mode as the injection mode and nitrogen as the carrier gas with the flow rate of 2 ml per minute. By using the column polar CP WETS 58CB column as the stationary phase, and the temperature was set up step by step starting from the 45 degrees Celsius to 245 degrees Celsius at 45 degrees Celsius per minute. FID was used as the detector and the temperature set up was 255 degrees Celsius. The retention time obtained for the whiskey is at 3.31 minutes.
For the conclusion, we are able to determine the most appropriate and rapid method of ethanol contents in alcoholic beverages.